Alright, currently you're watching video E5.p1-10, which is what causes the seasons. Alright, so in this lab, what you're going to do is you're going to investigate 4 different things, okay? Learning targets are, number 1, conducting a scientific investigation using appropriate tools and techniques. So that's E1.1c. E1.1d, which is identify patterns in the data and relate them to models. What you're going to be doing is collecting information as to why we have seasons here on Earth and then comparing it to the actual accepted reason as to why we do have seasons. The third is E1.1e, which is describe the reason for a given conclusion using evidence from your investigation. So when you're done and you write your conclusion, this will match this learning target because you're going to be using the information that you collect to support your conclusion on whether or not your hypothesis was correct or incorrect, whether or not you answered the problem, whether or not you use no pronouns, and whether or not you use data to support your hypothesis, right or wrong, and then eventually reasons for error. And then the last one, E5.p1-10, which is the primary ways to learn exactly why we physically have seasons on Earth. Okay? So the first thing that you'll do is you'll ask myself or Mr. Fuzak for the materials that we're going to be using for this lab to complete it. Once you have the materials, you're going to read the problem for this actual lab, which you'll find right here. Which position, A, B, C, or D, would Earth be in to have summer in the southern hemisphere? And I want to note it, that it is in the southern hemisphere I'm asking you. So we're going to actually think about something that's a little bit different to us because we live in the northern hemisphere. All right, so once you've read the problem, we'll create the hypothesis. And then, as it says again, read the problem for the lab. And it's noted twice here, so we'll have to erase one of those. And then we'll get into the procedures. Okay, we'll create our list for materials. We'll do our graph, we'll write our conclusion, and then the title and introduction for this actual lab in which we're going to perform. All right, so here's what you're going to do. I want you to think of a hypothesis as to why or where the southern hemisphere would be in during its summer months. Now, at this point you don't have to write anything down, but I want you to think about it when we start to read the procedures as to which location A, B, C, or D would we have the summer in the southern hemisphere. And we'll talk about when and where to write your hypothesis coming up. All right, let's get right into procedures. You're going to gather the lab materials from myself and Mr. Fuzak. What you're going to do is you're going to place a skewer, which is a stick that has a sharp end, and you'll see in this diagram right here, it looks to be like a pencil. And you're going to stick it right into the styrofoam ball. Pretty simple, pretty easy. Take the string and wrap it around the equator. Now, and then using the Scotch tape, you're going to tape it so that the string is attached around the equator. I'm going to tell you right now, if you can see on your white styrofoam ball where there is a seam line right smack dab in the middle of that styrofoam ball, which would be located right here where you see it say, where it states string at the equator. If you can see the seam, you may skip step 3 and step 4. There's no need for the string, there's no need for the tape. If you can see the seam. If you can't, then I would like you to complete step 3 and 4, with regards to taping it around the equator. And then using the masking tape, what you're going to do is you're going to create a label and put it at the very top to represent the North Pole. For some of you, you will know that that's already the North Pole, and for others, you may just need it as a to remember later on when you're asked to look at where the North and the South Pole are located. So I'll leave it up to you whether or not you need it or you don't, but just so you don't forget, it might not be a bad thing just to place that at the very top. So when it's all said and done, you should have something that looks very similar to figure 1 right here. All right. Now let's pay attention as to what you're going to do for step 6, 7, 8, and what you're going to be asked to do with each of those things. This is for steps 6 through 7. What you're going to do is you're going to set your flashlight right on the edge of a desk. And right now I'm actually in my basement on the steps because it's the darkest place in my house right now. But you'll set it right on the edge of your table. You'll turn the flashlight on. And then what you're going to do is you'll start by having the Earth model tilted away from it. And what you're going to do is observe exactly how much of the Earth is actually lit up compared to other portions of it. And after you do that, you're going to tilt it the opposite direction and notice how much of it is lit up. Alright, for steps 10 through 15, what you're going to do is you're going to gather a 30 centimeter ruler. Second, you're going to grab a flashlight. There will be multiple different types of flashlights, so this is just one example. You'll need a protractor. You'll need masking tape in order to do this. And what you will do, as it says on step number 15, you're going to take your flashlight and you're going to set it on the ruler, and then you're going to slide it up so that only 10 centimeters is remaining off the edge of your actual ruler. So 10 centimeters, and what you'll then do is you'll take your masking tape, and as it shows in the picture at step number 15, you're going to actually take the masking tape and wrap it around your flashlight so that it is connected to the ruler, so that you don't have to hold on to both of them, you'll just have to hold on to the flashlight. Alright, for steps 16, 17, and then a few after that as well, what you're going to start by doing is holding this at a 90-degree angle so that you can see the intensity of the light that is shown upon the actual graph paper that you have below it. And then what you'll do is you will then circle in the areas with the most intense light that are found on the graph paper. And you're going to use that so that you can then reference exactly the amount of intensity compared to other angles. And then what you'll do is you'll be asked to drop it to 45 degrees, and then you'll be asked to drop it to, I believe it is 2025, and the same thing. You're going to be sketching exactly how much of the intensity of the light which is shown upon the graph paper, and you'll be using that for later calculations. Alright, for procedure steps 27, 28, and 29, what you're going to do after you've constructed your protractor along with your scale of Earth, the model, and place it at 23.5 degrees from 90. So when you start at the very top and you moved yourself over 23.5 degrees and taped it so that this is centered, you'll have a model that looks like this, the tilt of the Earth. What you're going to do is you're going to start at step A, or A on the actual paper. And what you'll do is you're going to place this to be kind of perpendicular to it, so you'll notice that there's a tilt. Then what you're going to do is you're going to simply move from A over to B, and while doing so, you're going to notice exactly what's physically taking place with the amount of sunlight each portion of the Earth is actually receiving. And then you move over to C. And I'm not rotating the correct way, but this is just so you get a perspective. So then you'll be at C, and you'll be monitoring how much actual light is being received by Earth. Notice one thing, which is very, very, very important, that the tilt of the Earth is remaining the exact same. It is always tilted at that 23.5 degrees, and you're not switching it so that it's moving in this direction. The Earth doesn't rotate that way. It doesn't flip-flop its axis. What it does is it rotates itself on its axis, but always remains at the same tilt. So then when you move over to D, position D on here, you'll have the sun, and you'll also have how much light is shining upon the actual Earth, and then you'll move yourself back to A, which would complete one full year cycle as the Earth rotates around or revolves around the actual sun. Okay, so a couple things. One, the Earth rotates, spins on its axis, and it revolves, goes around, circles the sun. The second thing to note is that you'll notice how the piece of paper is labeled A, B, C, and D. The reason why is because the Earth revolves around the sun in a counterclockwise manner rather than a clockwise manner. Okay, so it revolves, I guess you could say, backwards, but it's counterclockwise. So that's why it's labeled A, B, C, D. And then your task, as you've been asked to solve for this problem, is which place, A, B, C, or D, would Earth be in the summer in the southern hemisphere. Okay, so keep that in mind as you go through this. Okay, now for steps 30 through 36, I believe, what you're going to do is you will gather a balloon and you'll have your flashlight. And what you're going to do is you're going to, as it shows in figure 4, you're going to take the flashlight and you're going to shine it directly upon the balloon to see what part is lit up when it's receiving direct sunlight. And then at indirect sunlight, higher up, you're going to place the flashlight to see the indirect sunlight that's being placed upon the balloon, and then also shine it down to the southern portion and see the indirect sunlight that is being received down there as well. Looking at how much intensity would be having a smaller space in which is lit up because all the light is being directed to that one space, versus indirect sunlight, which would be spread out and separated because it's not as intense in being directed to one specific location. So once you've done that, just noting your observations, you'll then go ahead and create your list of materials. You'll create your graph, you'll write your conclusion, title and introduction, and then you'll return the lab materials, and then see Mr. A or myself and Mr. Fuzak, to go over your lab. So data table here, graph space, and then your space for your conclusion located on the very last page. Okay? So if you have any questions, don't hesitate, let us know. It should be a pretty good lab. It should be a very interesting lab for most of you, especially when you have to create all the different little segments and put them together to make your Earth revolve around the sun.